Hello everyone, it's Mr. Kennedy here. In this video, I'm going to take you through 3 examples of questions involving equations of motion and projectiles. So these equations of motion questions involve movement in 2 dimensions, horizontal and vertical, and I'm going to show you how to tackle these questions and how to lay out your answers. First question, an aeroplane flying horizontally with a uniform velocity of 40 meters per second drops a food parcel which lands next to a wall. When the food parcel is released, the horizontal distance between the factory and the wall is 200 meters. And we've got to find out 3 things: what the time of flight of the food parcel is, how high the aeroplane is flying, and where is the aeroplane relative to the food parcel when the food parcel lands. The food parcel is moving in 2 dimensions. It's moving horizontally and vertically, which means it's a little bit trickier than just an equation of motion question in 1 dimension. So we start off in the same way. We have to choose our positive direction. In this case, we have to choose a horizontal positive direction and a vertical positive direction. As with previously, you're free to choose whichever directions you want to be positive as long as you stick with them. So in this situation, I've chosen to the right and downwards to be positive. The slight difference here as well is we have to have a horizontal and a vertical suvat. So I've got my horizontal one there, and then I've got my vertical. And then we just work through, as we did previously, we work through and try and fill in as much detail as we can about the aeroplane in this situation. So S, we know, is 200 meters for horizontal. The initial horizontal velocity is 40 meters per second, as is the final horizontal velocity just before the food parcel lands. The acceleration horizontally is 0, it travels at a constant speed horizontally, and the time is one of the things we're trying to find out. Vertically, we don't know the height, and we're trying to find that in part B. The initial vertical velocity is 0 because the plane is flying horizontally. It's not moving up, it's not moving down, so it's 0 to start with. We don't know anything about the final velocity just before the food parcel hits the ground, and we know the acceleration vertically is 9.8 meters per second, and again, we don't know time. So in these types of questions, time is the same for horizontal and vertical. Everything else is different, but time is the same in both the horizontal frame of reference and the vertical. So we can use vertical components or horizontal components to find time. So to find the time of flight of the food parcel, we don't really know a lot about the vertical motion, and we don't know S, we don't know V, and we don't know T, so we're really limited in what we can do there. But we do know quite a lot about horizontal, so I'm going to use the horizontal components to start with. So if we use the horizontal components to find time, we can use the equation S equals ut plus a half at squared. Filling in the data, we get 200 equals 40t plus 0.5 times 0 times t squared, and then that simplifies and we get the time of 5 seconds. Okay, part B, how high is the aeroplane flying? So the question here is relating to height. So that tells us that we need to use the vertical components now. So we now know the time, and the time is the same horizontally and vertically, is 5 seconds. So that will allow us to work out the height the aeroplane is flying using the vertical components. So use vertical components to find the height. Again, S equals ut plus a half at squared. There are other ways that you could do this question, and it's up to you which way you choose, as long as you end up with the same answer. If we put the numbers in and then we simplify, we get 122.5 meters or 120 meters to 2 significant figures. And finally, where is the aeroplane relative to the food parcel when the food parcel lands? So if we assume the aeroplane continues to fly at a constant speed in a straight line, then it will be 120 meters directly above the food parcel when it lands, because the food parcel and the plane have the same horizontal velocity. So the aeroplane will be directly above the food parcel when it lands next to the wall. Question 2. Larry the Lemming runs off the edge of a cliff after his pals at 5 meters per second. The cliff is a mere 45 meters high. And we've got to find out 5 things. What is his vertical velocity as he hits the water? How long, how much time does Larry fly for? How far from the bottom of the cliff does Larry land? And what is his horizontal velocity as he hits the water? Finally, what is his velocity as he hits the water? The first thing we need to do is choose the positive directions. So in this question, I've chosen to the left to be positive and down the way to be positive. I've then set out my horizontal and vertical suvats, and then have to try and fill in as much information as we can. So horizontally, we don't know the horizontal distance. That's one of the things we're trying to find. We know the initial horizontal velocity is 5 meters per second, as is the final horizontal velocity, because that's constant. The acceleration is 0 horizontally, and time is one of the things we're trying to find. We know the vertical height is 45 meters. We know the initial vertical velocity is 0. We don't know the final vertical velocity. That's what we're going to find in part A. And the acceleration is 9.8 meters per second. And we don't know time. That's another thing we're going to try and find. So to find the vertical velocity, the clue is in the question there, the vertical velocity. That means we need to use the vertical components. So we're going to use the vertical components to find the velocity. So v squared equals u squared plus 2as. If we put the numbers in and then simplify, we get a final vertical velocity of 30 meters per second. For part B, how long does Larry fly for? We're looking for time here. So as I said in the previous question, you can use horizontal components or vertical components to find time. Time is the same horizontally and vertically. In this question, we don't have enough information horizontally because we don't know S and we don't know T. So that means we really have to use the vertical components to find time. So if we use the equation V equals U plus AT and put the numbers in and then simplify, we get T equals 3.1 seconds to 2 significant figures. Okay, part C, how far from the bottom of the cliff does Larry land? So again, hopefully by reading the question, you get the sense that this is talking about something horizontally. It's how far from the bottom of the cliff. So for this question, we need to use the horizontal components. So using those and the equation S equals UT plus a half AT squared, just putting our data in, we get S equals 16 meters to 2 significant figures, so 16 meters from the bottom of the cliff. Question D, his horizontal velocity as he hits the water. Well, horizontal velocity is constant. So he started off at 5 meters per second, so his horizontal velocity just as he hits the water would also be 5 meters per second in the same direction that he was running to start with. Then finally, part E, to find his actual velocity as he hits the water, we need to combine the horizontal and the vertical components of his velocity. So we do that using vector addition. So I've started off with the horizontal, and you could start off with the vertical. So I've drawn 5 meters per second to the left, and then from the end of that vector, I've drawn 30 meters per second down the way. We worked out the final vertical velocity in part A. Then the resultant vector is then just from start to finish, and then we need to try and find out this angle here that gets us from the starting point to the finishing point. So to find the magnitude of the velocity, we use Pythagoras, so it gives us 30 meters per second. It's actually just over 30 meters per second, but when we round it to 2 significant figures, it comes out as 30. And then if we use trigonometry, SOHCAHTOA, to find the angle, we get the angle is equal to 81 degrees. So then to write the final answer for the final velocity, we say that the velocity is 30 meters per second at an angle of 81 degrees from the horizontal. Or you could also say 9 degrees from the vertical or from the cliff face itself. The third and final question from this video is an old past paper question. So it's about a fun fair where a prize is awarded if a coin is tossed into a small dish. The dish is mounted on a shelf above the ground as shown. So we can see the path of the coin as it leaves the contestant's hand and lands in the dish. So they project a coin with a speed of 7 meters per second at an angle of 60 degrees to the horizontal. When the coin leaves his hand, the horizontal distance between the coin and the dish is 2.8 meters. The coin lands in the dish, and we can ignore air resistance. And we've got to find the initial horizontal and vertical components of the coin. And we have to show that the time taken for the coin to reach the dish is 0.8 seconds. And we've got to find the height of the shelf above the point where the coin leaves the contestant's hands. So the first thing we need to do is choose the positive directions. So I'm going for to the right and up the way because that's the initial directions that the coin is travelling in. We then write down the horizontal and vertical suvat. So we don't know a lot at the moment about this. So we can actually, if we start off by finding the horizontal component and the vertical component of the velocity, that'll make things a little bit easier. So the horizontal component, as we learned, is found by v cos x. So 7 is the initial velocity, the angle is 60 degrees, so that gives us an initial horizontal component of velocity of 3.5 meters per second. Similarly for vertical, we use v sin x to find the initial vertical component of velocity, and that gives us 6.1 meters per second. So if we now go back and look at suvat, we know the horizontal displacement is 2.8 meters. We know the initial horizontal component of velocity is 3.5 meters per second. This is really important. It's the initial horizontal component of velocity we use here. The final horizontal velocity will be the same. Acceleration horizontally is 0, and we don't know anything about time. In fact, we've got to show that in part B. S, we don't know vertically. That's one of the things we're trying to find out in part C. Initial vertical velocity is 6.1. The final velocity we don't know anything about. Acceleration is minus 9.8 meters per second because that acts down the way. And again, we don't know time. We're trying to show that in part B. So on to part B. If we use horizontal components here, I'm going to use horizontal components because for vertical we don't know S, V or T. So that kind of forces us to use the horizontal components this time. And if we use the equation S equals ut plus a half at squared, put the numbers in and simplify, we get a time of 0.8 seconds as we were asked to show. Just make sure if you're answering a question like that, you always give your final answer exactly as it's shown in the question. So in this case, 0.8 seconds. For part C, we're trying to find the height h of the shelf above the point where the coin leaves the contestant's hand. So because we're trying to find a height, we need to use the vertical components this time. And we can use the equation S equals ut plus half at squared this time, but using vertical components. Substitute the numbers in, and that gives us an answer of 1.7 meters above the point where it left the contestant's hand. I hope you found this video useful. Thank you very much for watching.